What is up, my little grade 2 buddies? Today I've got a great lesson for you. We're going to be learning everything that you need to learn about grade 2 fractions. Today we're going to have a look at an introduction to fractions, looking at tenths and where it sits on the place value chart. Then we'll look at some common fractions that you should be able to easily recognize. Then we'll have a look at fractions of amounts in both unit fractions and non-unit fractions and learn exactly what that means before looking at equivalent fractions and then adding and subtracting fractions. And then towards the end we'll have a look at ordering and comparing fractions, and then we'll look at some fraction word problems for you to try and solve as well. So let's waste no time, let's jump in to lesson 1.
Okay, well, what do we need to remember today? We need to remember that fractions are just part of a whole. So what does that mean? Well, we can look at it like this with our place value chart. Hopefully we've seen a place value chart like this before with ones, tens, hundreds and thousands, etc. But where is the place for our fractions? Well, our place for our fractions actually comes after the ones. Because remember, a fraction is smaller than 1. It's a part of 1. So we would end up having to put this extra section that we will then call tenths. And don't forget, we would need our decimal place between them. This decimal point shows that we're now less than 1 and we're into fractions. And the reason it's tenths is because if we think about it, everything going positive across our place value is multiplied by 10. So 1 to 10, 10 to 100, and 100 to 1,000. They're all multiplied by 10. So everything coming down the place value chart is divided by 10. So 1,000 down to 100 is divided by 10. 100 down to 10 is divided by 10. 10 down to 1 is divided by 10, and therefore 1 divided by 10 equals tenths. So our new column is the tenths column. Now let's have a look at it another way. This is my 1. I have 1 bar of chocolate. So at the minute I have a whole 1. However, we can see that it's been cut into 10 even pieces. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I have 10 equal pieces. So therefore, one of these pieces is worth 1/10. Or in other words, we can write it into our fractions. We split our whole into 10. So the number on the bottom would be a 10. And I have only one of them, so I have 1/10. Now at this point it's quite important to learn what we call these different numbers. The number on the top is the numerator, and the number on the bottom we call the denominator. And their jobs are pretty important. The number on the bottom shows how many we've split our whole bar into. In this case we split it into 10. And the numerator, the number at the top, shows how many we're focusing on, how many we're looking at. And in this case, it'd be 1. So what would I have if I actually shaded another couple of these sections up? Well, I had 1/10, this one here. Then I had another 10th, and then I had another 10th. So altogether, I have what? Well, I can see I have 1, 2, 3, and we still have 10 sections to our chocolate bar, so my denominator is still 10. So here I have 3/10. So if we were to look at the individual parts, here we can see I have 1/10 of my original chocolate bar. Now I have 2/10, then 3/10, then 4/10, then 5/10. We can see we're counting up in tenths. 6/10, 7/10, 8/10, 9/10, and then finally 10/10, or in other words, 1. Because 10/10 makes back up our original 1 chocolate bar. So 10/10 is equivalent or the same as saying 1. So looking back at our place value chart, what we have to understand for this lesson is that this extra column now, our 10th column, is a fraction. It's part of 1. So if I had 1 whole, but I split it into 10 pieces, each piece would be worth 1/10. Or in other words, a 1 in my column. Awesome, so that was a quick introduction to fractions. In our next lesson, we're going to look at what equivalent fractions are. So make sure you stick around for that. But today we want to remember that a fraction is an equal, it's a very important word in fractions, part of a whole. We can show fractions of tenths in the place value chart. The number at the top of a fraction, so this number here, would be our numerator, and the number at the bottom of the fraction, this number here, would be our denominator. Remember that denominator shows us how many we've split our whole into, and the numerator is how many we're counting.
Okay, great. Now we've just looked at where fractions sit on our number line and what a fraction actually is. Let's have a little look at some common fractions that you should be able to recognize. Let's go.
Okay, so what do we need to remember for this lesson? We need to remember that a fraction is just a part of a whole. So for example, if we had this whole apple here, a fraction would be when we cut it into equal parts. So here we have half on this side and half on that side. But there's lots of different fractions that we can make. Let's start by looking at half. Now this looks a bit of a fancy way of showing a fraction, doesn't it? With this 1 on the top and 2 on the bottom. So let's learn what that means. Well, the number on the bottom, we call this the denominator. And what that tells us, it tells us how many our half has been cut into. So if we look back to our apple, it means that we had our whole apple and we've cut it into 2 equal pieces. And then the number on the top, the numerator, that tells us how many pieces we're looking at. So we're looking at this 1 piece here. Therefore, this pink shaded area is 1/2. So if we imagine a number line, I've got a very small part of my number line here, starting with 0 and going to 1. But remember, our number line could go on forever this way, and it could also go on forever into the negative numbers. This is a very small part of our number line. Half is actually right in the middle here of our 0 and 1. Because if you think about our apple again, if we had no halves, that would mean we had 0. And then if I had 1/2, that would mean that I'm in the middle and I have 1/2. Or if I had 2 halves, that would be the same as saying I have 1. But obviously circles are not the only way we can show half. If we look at our square here, I could show half by cutting a line down the middle. That would show that I have half on either side. Or what I could do is I could cut my line diagonally to diagonally, and I would have 1/2 on either side. Or what I could do is I could cut my square in half and half again, and I could say that you have this square and this square. Well, that's also showing half, isn't it? You have half of the squares that are available. Or our final way of looking at what half is we can look at half of an amount. And in this case, we have an amount of marbles. We have 1, 2, 3, 4, 5, 6, 7, 8 marbles. We want to try and find half of them. So the way I want to think of it is, all of these marbles together is one group of marbles. If I'm going to split them in half, I need to make 2 piles. And I can make 2 piles by simply cutting down this line here and having 2 equal piles of 4. Let's check. 1, 2, 3, 4, and then 1, 2, 3, 4. So half of my 8 marbles here would be this 4 right here. Whoa, 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 whoa. Have you clicked that subscribe button yet? If you've not, what are you doing? Do it now. Go on, press it. Do it. Thank you. Okay, but let's look at another fraction. This is another fraction that we should get familiar with. This is the fraction 1/4. And let's remember what we need to do. The denominator, the number at the bottom, tells us how many I'm going to split my whole into. So I have my whole apple, but I'm going to split it into 4, because that's what my denominator tells me to. And then my numerator, the number on the top, tells me how many I have. And I have 1/4. So I have one little section up here. And again, looking at my square, I could do this in a number of different ways. I could cut down the middle and then through the middle and give myself 1/4. Or I could go from the diagonal corners and give myself 1/4 like that. There's lots of different ways I could make this shape into quarters. Looking on my number line, I would have to see that my 0 is here, my 1 is here, so therefore 1/2 is in the middle, like we saw in the last slide. So where does 1/4 fit? Well, we can see that 1/4 is like saying half of a half. This was my half, all of this side here, and 1/4 is half of half again. So 1/4 would go halfway between my 0 and my half. Or if I'm trying to find 1/4 of these marbles, I can see that I have 8 again. 1, 2, 3, 4, 5, 6, 7, 8. So when we have this group of 8 marbles, if I want to find a quarter, I've got to split them into 4 equal groups. And I can see that I can do that by putting 2 together. That would be 1 group, 2 groups, 3 groups, and 4 groups. So 1/4 would be 2 marbles. Our last fraction that we would like to try and learn is what 1/3 is. And again, it's the same principle. All it means is that we've cut our whole into 3. And there's a fancy way of doing this with our pizza. We can cut down from the top into the middle and then split out to the sides. That gives me even 1/3. And I can see that 1/3 is valued like this. So it's more than a quarter, but not as much as half. If I'm doing that with my square, I can make 3 equal columns and have 1/3 colored in green. And on my number line, 1/3 means that I've split my 1 into 3. So I would have 1 section, 2 sections, and 3 equal sections, meaning that the green section is worth 1/3. And 1/3 of my balls means that I'm putting them into 3 equal piles, and 3 equal piles here means that I have 3 in each. This fraction is a little different. This fraction has a different numerator. Now I have a 3 on my numerator. So this fraction says 3/4. So it means that I've split my whole into quarters, but this time, rather than looking at just 1/4, which would look like that, I need 3 of them. This would be 2, and then 3/4. And again, with my square, cutting it into quarters, or 4, and then I would have 1, 2, 3 of them. On my number line, I'd have to remember that this is my half. 1/4 would be over here. So therefore, if I have 1/4, the next section would be 2/4, and then the next section would be 3/4. So 3/4 would come all the way to my gold line here. What if I wanted to find 3/4 of an amount? Well, in this case, I have 9 marbles. Well, in this case, I have 8 marbles. So to find 3/4, I need to put them into 4 equal groups again. So I've got 1, 2, 3, 4 equal groups. But 3/4 would be 1, 2, 3 of those groups, which is 6 marbles. So 3/4 is another really important fraction to understand. Let's look at what to remember. Fractions are an equal part of a whole. We can find fractions of a number, shape, or even a quantity. And there are 3 fractions, that's meant to say you, should recognize: 1/2, 1/4, 1/3, And then if you're super smart, you might want to start recognizing 3/4 2.
Awesome. So that's what fractions are and some common fractions. Now let's look at something a bit more complicated. Let's have a look at how to find fractions of an amount and learn exactly what this means. First, we'll look at unit fractions.
Now, the very first thing we need to remember today is that fractions are just a part of a whole. If you didn't watch the introduction lesson to fractions, go back on the channel and find that lesson first. But essentially, all we need to know is that fractions are just a part of a whole. And today we're looking at something special. We're looking at unit fractions. And what a unit fraction is? A unit fraction is when we have a 1 as our numerator, the number on the top. So that brings me to the first point that we need to remember. When we're looking at a fraction, for example, this 1/6 over here, we have two numbers. The number on the top is called the numerator, and the number on the bottom, the denominator. The denominator tells me how many I've split my whole into. So I have my whole pack of marbles here, and I've split them into 1, 2, 3, 4, 5, 6. And the numerator is how many we're trying to focus on. So in this case, 1. So let's look at what our question is asking us in this first example. It says find 1/6 of these marbles. Now, this first one's pretty easy because we actually only have 6. So my denominator is the same amount that we have when we've split our marbles up. We have 1, 2, 3, 4, 5, and 6. So I don't need to do any extra maths there. So to find the quantity, to find how many of these marbles 1/6 is, all I need to do is colour one of them and understand that therefore one of them is now green. So my answer to what 1/6 of these marbles is just 1. But question 2 is a lot harder because look, we have find 1/3 of these marbles, and I have a lot more than just 3. If I had these 3, it would be very easy. I could just simply colour one of them and get the same answer as 1. But it's not. I have more than 3. So my first job now, I have to split these into 3 equal groups. So how can I make 3 equal groups? Well, I'm going to make 3 circles. 1, 2, 3. These are my sharing circles. And then I'm simply going to put these marbles inside my 3 sharing hoops. So I'm going to put this one in here. I'll put the number 2 in here. 3 in here. Carry on just like this. 6 and 7, 8, 9, 10, 11, and 12. Now, there's something I need to check. I need to make sure I have the same amount in each of my sharing hoops. So I have 1, 2, 3, 4. Good. 1, 2, 3, 4. And 1, 2, 3, 4. Perfect. So I know I've shared these evenly. And now because I've shared them into 3 equal piles using my denominator, remember my denominator is what tells me how many piles I need to make. To find out how many is 1/3, all I'll do is count one of my sharing circles. How many do I have in here? Well, I have 1, 2, 3, 4. So therefore, finding 1/3 of these marbles equals 4. Simple. But sometimes we don't have marbles. Sometimes we just have a question. This question says, find 1/5 of 25. Well, if I don't have marbles, I can still make them using a spare bit of paper or a bit of my board here. So, how many marbles do I have? I have 25. And I'm trying to find 1/5. So, the most important starting position is my denominator here. So I need to share my 25 marbles evenly between 5 groups. So I'm going to draw my 5 circles, 1, 2, 3, 4, 5, and then I'm simply going to share my 25 marbles evenly between these 5 sharing circles. Here we go. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Let's just quickly check that they all have the same amount. I have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Good, so we know that each one has 5. Therefore, when I'm finding out how many is in 1/5 of these amounts, I can just focus on one circle and see that I have an answer of 5. Easy, right? Let's look at what to remember. Unit fractions are fractions where the numerator, the number on the top, is a 1. When we're trying to find a fraction of an amount, like today's lesson, we use the denominator, the number on the bottom, to create equal groups. So for this example, I would need 3 circles because I have a denominator of 3. So then I'm going to count how many is in each group and then simply look at the numerator to tell me how many groups I want to count the total for, and that's going to give me my answer. Your turn. Find 1/4 of these marbles. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16 marbles. I want you to tell me what 1/4 of them are. If you're struggling, go back to the beginning of this video and watch it again. I promise the second time it makes a lot more sense.
Okay, cool, now we've looked at unit fractions, let's learn what a non-unit fraction is and see the same process with non-unit fractions. Let's go.
Okay, the first thing we need to remember is that fractions are a part of a whole. So when we're talking about fractions, we're talking about values that are less than 1. And we have this fancy little name here, non-unit fractions. This is the second of 2 lessons. If you've not looked at the unit fractions lesson, I would suggest you stop this video and watch that lesson first, because you might need to know some of those skills before you understand non-unit fractions. But essentially, a non-unit fraction is a fraction, let's look at this one here, where the number on the top is more than 1. So in this case 2, and in this case we have a 3. And working out fractions of amounts with a non-unit fraction means we have one extra step. So let's have a look at this first question. It says, find 2/3 of these marbles. Okay, well, what do we need to do first? Well, we need to remember what our fraction stands for. And the number on our bottom is what we call the denominator. And this tells us how many we need to split our whole, so in this case our whole amount of marbles. It tells us how many we need to split them into. We can see we have groups of 3 because our denominator is a 3. And then the number on the top, we call this the numerator. And this then tells us how many of those groups of 3 we need to add up and look at to get our final answer. So that might sound a little bit complicated. Let's see it in practice. So we can see I have 1, 2, 3, 4, 5, 6 marbles. And to find 2/3 of them, I need to split them into 3 equal piles. So I'm going to put my 3 sharing circles out, 1, 2, 3, and then I'm going to simply share them into these 3 circles. So I'll put number 1 in here, number 2 in here, number 3 in here, number 4 back in the first one, number 5 in the second, and number 6 in the third. And then the first job I need to do is just make sure I have the same amount in each one. I have 2 in here, 2 in here, and 2 in here. So I've done that right. But then my question asked for what 2/3 are. So this would be 1/3, because this is one of the circles. So therefore 2/3 would be 2 of the circles. This is 2/3, because each of those little circles is equivalent to 1/3. So to get 2/3, I need to count 2 of the circles. So how many marbles do I have in 2 of these circles? I have 1, 2, 3, 4. So my total answer is 4. 1/3 of 6 equals 4. Awesome. Let's look at this second one. find 3/4 or 3/4 of these marbles. Well, let's count how many I have first. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So I have 16. So my question is, find 3/4 of 16. So remember what we need to do first. We need to look at our denominator, quarters or fourths. So I need 4 sharing circles. 1, 2, 3, 4. And then I'm going to simply share my marbles between these 4 sharing circles. So this first one will go in here, second, third, fifth, sixth, seventh, and eighth. And the ninth one will come back in the first, 10th in the second, 11th in the third, 12th in the fourth, 13th back in the first, 14th back in the second, 15th in the third, and 16th in the fourth. And again, let's just check we have the same amount in each one. I have 4 here, 4 here, 4 here, and 4 here. Good, so I know I've not made any small mistakes. And now I need to understand that each of these circles is 1/4. So to find out what 3/4 is, I can't just count 1 circle. I have to count 3 circles. And in these circles, I can say I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 marbles, meaning my answer to finding 3/4 of these marbles equals 12. Awesome. But sometimes we don't have marbles. Sometimes we just see the question like this. Find 3/5 of 25. And this looks so much harder when we don't have those marbles. But remember, we can still use scrap paper or my screen around me to help me. So I'm going to draw and I'm going to see it in practice. So how many do I have? I have 25. And I'm trying to find out what 3/5 are. Remembering that my 5 is the denominator, meaning that's the amount I'm going to share my 25 between. So I'm going to share it between 1, 2, 3, 4, 5. And I want to count 3/5. So I'm going to be looking at these 3 circles here. Now I'm just going to share my 25 out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. But remember, I don't just want to count how many is in 1 circle. I'm looking for these 3 circles, and I have 5, 10, 15. So my answer to 3/5 of 25 equals 15. And I got there by drawing out my marbles and my sharing circles. Let's look at what to remember. A non-unit fraction are fractions where the numerator, the number at the top, is more than 1. And we use the denominator, the number at the bottom of our fraction, to create equal groups, and then we just share our quantity out and then count how many is in the numerators. That will give us our total answer. Your turn. Find 2/4 or 2/4 of these marbles. Press pause on the video now, take your time, good luck.
Whoa, there's so much learning going on there. Now, I would say this next part is one of the most important aspects of fractions. We're going to start to look at equivalent fractions. Equivalent means it's the same value, but might look a little bit different. But let's learn it in the lesson. Let's go.
Okay, so the first thing we need to think about is step 1. Equivalent means the same value. So it means we've got a fraction, for example, this 1/2, but we make it look different by giving it different numbers, but we keep it the same value. And to do that, we can use multiplication and division. So that might sound confusing. Let's learn. Now, the first thing to learn is what our 2 numbers are called on our fraction. So if we look at this fraction here, we have 1/2. Well, the number on the top, in this case a 1, is called our numerator. And the number on the bottom is called our denominator. So understanding these 2 terms right at the start of this is really important. Now, like I say, an equivalent fraction holds the same value but will have different looking numerators and denominators. Now let's use these two chocolate bars, our bar models over here, to show what I mean. So if we make this first chocolate bar a half, which is what we've got here as our example, we would cut our chocolate bar down the middle and create two equal halves. Remember, a fraction has to be equal. So my blue half is the same as my pink half. But that's not the only way we could have chopped this chocolate bar. What I could have done is chop it into 4 equal parts. So cutting in half and then cutting these halves into half again. That would mean that each of these sections is worth 1/4. We can see that each of them is the same and they each hold the value of 1/4. Now if I wanted to have as much chocolate bar in this second one as I had in the first one, I would have to not have 1/4, but I would need to have another one too. So I would have 2/4, and we can see that my blue section is the same value, the same amount. But in this fraction, we were cut into quarters, so my denominator was quarters, and I had 2 of them to make my equivalent fraction. So therefore 1/2 is equivalent to 2/4. So 2/4 is an equivalent fraction. And we could keep going. I could make another chocolate bar down here, but this time I could chop it not just into quarters, but into eighths by cutting all of these quarters into half again. That means each of these individual sections has a value of 1/8. Well, how many eighths do I need to get to my half, which will be all of this blue section? Well, I need 1/8, 2/8, 3/8, and 4/8. So 1/2 equals 4/8. So this is one way of looking at it, by drawing these individual pictures, but step 2 said that I could use multiplication and division. Let's see what that means. So if I start again with my 1/2, and let's put it into this first chocolate bar, I have 1/2, which means I have this shaded area here. But I know that if I had cut my pizza or my chocolate bar or whatever it is into 4, that I would actually have 2/4. So 1/2 is equivalent to 2/4. So let's look at how we can use multiplication to help us understand this a bit clearer. Let's have a look at our denominators here. Well, I started with 2 and I ended up with a 4. So how did I get from 2 to 4? Well, I multiplied it by 2. And let's have a look at our top numerator. I started with a 1 and I ended up with a 2. And how did I get from 1 to 2? Well, I also multiplied by 2. And because we've done the same to the bottom as we have done to the top number, or the same to the numerator as we have to the denominator, by multiplying it by 2, we are going to end up with an equivalent fraction. This part might sound a bit confusing because we haven't got these bar models to look at and check, but let's have another go. Let's see what happens if I multiply my 2, this time by 4. Well, 2 times 4 is 8. Okay, well remember, what I do to the denominator, the number at the bottom, I have to do to the numerator if I want it to stay equivalent. So 1 times 4 equals 4. Okay, 4/8 is my equivalent fraction. And I can check that on my chocolate bar over here by cutting my chocolate into 8. So here we go. There we go, I have 8 equal parts. And I think that 4 of them, so 1, 2, 3, 4, is equivalent to half. Well, I can see that it is. Good job. Whoa, whoa, whoa. If you're not a subscriber yet, make sure you press that subscribe button. It really helps the channel out. Thanks very much. Let's get back to the video. Let's look at a different one. Let's look at 2/6. So 2/6 on our chocolate bar would look like this. I've cut my chocolate into 6 and I have 2 of them. Okay, well, let's see if I can make some equivalent fractions. Let's see if I cut my chocolate bar this time into 12, which you can see I've done by just putting another line horizontally through my chocolate bar. So each of these little sections is worth 1/12. So how many twelfths do I need to be equivalent to my 2/6? So I'm going to draw this little box here so we know how much I need. Well, I'm going to need 1, 2, 3, 4. So therefore 4/12 is equivalent to 2/6. And let's check that by checking our multiplication is correct. So how did we get from 6 to 12? We multiplied by 2. And how do I get from 2 to 4? I multiplied by 2. So because we multiplied the numerator by 2 and the denominator by 2, we know it has to be equivalent. Awesome job again. But so far we've only looked at multiplication. Let's see how we can use division to find equivalent fractions too. So I'm going to draw my 2/6 again in this top box. There we go. I'm going to get my 1/2/6. Good. But I want to try and divide my fraction and see if I can find another equivalent fraction. So let's divide my 2 by 2. So 2 divided by 2 equals 1. Now whatever I did to the numerator, I'm going to do to the denominator. So I'm going to do my 6 divided by 2 as well. That equals 3. So I think 1/3 is an equivalent fraction or has the same value. Let's see. This time I'm going to get my chocolate bar and I'm going to just cut it into thirds. There we go. Each of these sections is worth 1/3. Now I'm trying to find an equivalent fraction of 2/6. So it's going to be all over this part. And we can see that 1/3 has the same value, or in other words, is equivalent to 2/6. Great job. Let's look at what to remember. Equivalent means that the fraction will have the same value. For example, 1/2 has the same value as 2/4. If someone said to you, do you want 1/2 of my pizza or 2/4 of my pizza? It doesn't matter because it is the same. It just looks different. To make equivalent fractions, we can use multiplication or division. But remember, whatever we do to the numerator, we must do to the denominator to make sure it stays equivalent. Your turn. Have a go at answering these two questions and find a couple, which means maybe one or two, equivalent fractions for them. So find some equivalent fractions to 4/5 and find some equivalent fractions to 1/4. If you'd like to draw chocolate bars, go for it. Or if you'd like to just use multiplication and division facts, you can do that too. Put your answers in the comment section. I'm going to try and mark them all.
Awesome, we're getting towards the end of the lesson now. Hopefully this is starting to make sense. If it's not, please feel free to go back and watch the various different parts before moving on. But right now, we're going to look at how to add and subtract fractions that have the same denominator. Let's jump into it.
Now, what we want to remember in this example is that when we are adding and subtracting our fractions, the denominator will end up being the same. But what does that mean? Well, let's have a look at our first example. 1/4 add 2/4. We should know by now that the number on the top of any fraction is called the numerator. And the number on the bottom is called our denominator. And the denominator is how much we've split our chocolate bar or whatever it is into. So 1/4 would mean that I've cut my chocolate bar into 4s or quarters. And the 1, the numerator, is how many we're looking at. So in this case, 1/4 would look like this. Okay, and then we're going to add it to my second fraction here, which is 2/4. So again, I'm going to get my new chocolate bar, cut it into 4s, but this time instead of 1/4, I have 1/2. So when I'm adding them, I can simply just count how many quarters I have. So when it says here that the denominator will stay the same, what it means is you're adding quarters. Your quarter is here and your quarters are here. So you're adding quarters. It's almost like saying you're adding elephants. If you add 1 elephant to 2 elephants, you're always going to have elephants as an answer. You're going to have 3 elephants. You're not going to start having cheetahs or dogs. So in this case, it's exactly the same. 1/4 added to 2/4 is going to equal something amount of quarters. So my denominator will always be in quarters, because that is what we're adding up. We're adding quarters. And let's check how many I have. Well, in my first chocolate bar, I have 1/4. That's my fraction here, 1/4. And in my second one, I have 2/4, 1, 2. So together, I have 1, 2, 3/4. So my answer to 1/4 add 2/4 is 3/4. Whoa, I'm going to stop the video right now. If you're not a subscriber, what are you doing? There's loads of learning you can do on this channel. Press the subscribe button right now. It really helps me out. Thanks very much, guys. Let's get back to the learning. Let's see if that works with subtraction. So my question now is 5/6 minus 2/6. So I can see now my chocolate bar is always cut into 6. So I'm working with 6. It's 5/6 subtract 2/6. Just like 5 elephants subtract 2 elephants. So my answer has to be in 6. Now let's draw out our chocolate bars. Let's cut it into 6. There you go. I've got 6 equal parts. And in the first fraction, I have 1, 2, 3, 4, 5, 6. But then I'm taking away 2/6. So I don't need my second chocolate bar here because I'm not adding. I'm actually taking away. So what I'm doing is I'm removing 2 of these 6. So I could remove this one and I could remove this one. I could take them away. And how many does that leave me with? Well, I have 1, 2, 3 left over. So my answer to 5/6 subtract 2/6 is 3/6. Now some bright sparks between you will start to notice that all we're doing really is keeping the denominator the same. And if I'm working in 6, I end up with a 6, and then I'm just using the operation on the numerator. 5 subtract 2 equals 3. Let's see if that works for the first one. We kept the denominator the same as a 4, and then I just did 1 plus 2 equals 3. So it's actually super simple. Let's look at a couple of harder ones, but without pictures this time. So if I have 2/8 plus 3/8, I know I'm working with 8s. So I know my answer is going to be in 8s. And then all I need to do is add my numerators. 2 plus 3 equals 5. 2/8 plus 3/8 equals 5/8. Let's have a look at the next one. We have 6/7 minus 2/7. So I know my answer is going to be in 7ths. And then I can just do 6 minus 2 equals 4. 6/7 subtract 2/7 equals 4/7. How easy is that? Remember, when adding and subtracting fractions, the denominator never changes. We can simply add or subtract the numerators. And if we want to, we can use pictures to check our work. Your turn, have a go answering these 2 questions. See if you can press pause on the video now and get the right answer. Put your answers in the comment section. Press pause now, good luck. Whoa, we're so close. This is our penultimate, which means our second to last lesson. We're looking at how to order and compare fractions, so putting them in order from, say, smallest to largest, or saying which one is bigger than others, and we'll learn how to do that. Let's go. Okay, so the thing we need to remember today is that the denominator splits our bar, or splits our whole, and then we're going to count the numerator. But that might not mean much at the moment, so let's first understand what numerators and denominators are. So if we're looking at this first fraction, 2/7, the number on the top, this is what we call our numerator. And the number on the bottom, this is our denominator. And what it essentially means is that the number on the bottom is how many we're going to split our whole into. So if we have our whole chocolate bar here, if we're looking at 7ths, as in our denominator is a 7th, it means we're splitting our chocolate into 7 even pieces. So let's do that. There we go. So we have 7 pieces that our chocolate bar has been split into. And our numerator means how many we're going to be looking at. So if it's got 2/7, it means that we've got 1, 2 of these individual 7ths. because each of these little sections is worth 1/7. So when we're ordering and comparing fractions, what we want to see is which one has the smallest and which one has the largest value, and then we'll put them in order. So let's carry on breaking these fractions up. Let's look at question number 2, 1/7. So again, I'm going to split it into 7 equal pieces. There we go. But in this one, I only have 1/7. So it means I'm only going to colour one of these sections, 1/7. And finally, with our last one, we have 6/7. 6/7 still means that we're going to split it into 7. There we go. But this time, I have 1, 2, 3, 4, 5, and 6 of them, with each one being 1/7. So now when we're ordering them, we want to put them in order of size. And let's say we're going to go in ascending order, which means that we're going to go from smallest to largest. So we need to put these fractions from the smallest to the largest. Well, which one has the smallest value? Well, if I was going to have one of these chocolate bars, the one that has the least would be this one, my 1/7. I only get a very small little part of the chocolate bar. So my first fraction in order would be 1/7. Then, which is the next smallest, we can see I have 2/7. So my next one would be 2/7. And then the biggest one, the one with the greater value, has 6/7. So when I'm ordering these three fractions, the correct order from smallest to largest would be 1/7, then 2/7, then 6/7. And what we should be able to see is that that's pretty easy to see when our denominators are all the same. We have sevenths. So what we can really do is just look at the numerator and just see that this is only 1/7. So that's obviously a very small amount. Then we have 2/7, a little bit more, and then 6/7, nearly a whole chocolate bar. So when our denominators are the same, all we really need to do is look at the numerators and put them in order. So this way round, this is what we called the ascending order from smallest to largest, but we could have the opposite. We could have the descending order, which means that our numbers go from largest to smallest. So the descending order would therefore be 6/7, then 2/7, and then 1/7. Whoa, guys, if you are not a subscriber, what are you doing? Press that subscribe button now so you don't miss out on any more learning. Let's get back to the video. Let's look at how we can compare these two fractions. And again, what we can notice is I have the same denominator in both. And when we come to comparing, we have three very important symbols that we might use to help compare. We have greater than, and we say this is greater than because the number on the left-hand side, let's imagine I have 5 here, would be greater than 3. And we know which way round I want to put this little triangle thing, which we call a crocodile, because he would want to eat the bigger number. If we make this little triangle into a crocodile, he would eat the bigger number. 5 is bigger than 3. But it could be the other way around. I could have 3 on this side and 5 on the other side. And that would mean that 3 is less than 5. And again, the crocodile would want to eat the bigger number. So this number sentence says 5 is greater than 3, and this number sentence says 3 is less than 5. But we also have another symbol. We have the equals symbol, because sometimes some things are equal. I might have 5 on one side. 5 is equal to 3 add 2. They are both the same value. So therefore, the symbol would be equals. So let's put those 3 symbols over in this corner so we know where they are for later. We're going to end up using one of these in our circle here to compare my 4/6 to my 3/6. But let's first of all see which one's going to be bigger or smaller. So again, I'm going to use my denominator to help me cut my chocolate bar into 1, 2, 3, 4, 5, 6 pieces. And again, on my second one, I have 1, 2, 3, 4, 5, 6 pieces. But on this first one, I have 4 of them. 1, 2, 3, 4. And on the second one, I only have 3. 1, 2, 3. So we should be able to see that the greater value, the bigger value, would be 4/6. So therefore, going back to my symbols, which one would the crocodile like to eat? Well, the crocodile will eat the bigger value. Therefore, my crocodile face will face the 4/6. And my number sentence reads 4/6 is greater than 3/6. And that's how to order and compare fractions. If we're ordering, we can use ascending, which means going from smallest to largest. Or we could use descending, which is from largest to smallest. And then when we're comparing, we could use the greater than, the less than, or the equal to symbol. Let's look at what to remember. First, we're going to check the denominators are all the same, because when we're comparing, we want our denominators to be the same. Then we're going to draw a bar model to help us see the fraction. Just like we did here, we drew these bar models to help us actually see which one's greater. Then the numerator tells us how many to count in the fraction. Again, our 4 told us to colour 1, 2, 3, 4, and our 3 told us to colour only 1, 2, 3. Once we've done that, we can clearly see which one is bigger or smaller. So your turn. Here are 3 fractions. I want you to have a go at putting these in order from smallest to largest. Have a go at thinking about this now. Press pause on the video. Put your answers in the comment section. I'm going to try and mark them all. Good luck.
Wow, we're doing so well. This is our last lesson now. Let's look at how we can use all these skills into word problems. Let's go.
What is up, everybody? Welcome back to the Math Guy. Today we're going to look at how to solve fraction word problems using a tactic called rucksack. So let's waste no time. Let's go. Okay, so what is rucksack first of all? Well, rucksack stands for, rucksack is made of an R, a U, C, S, A, and C. And what it stands for is a little acronym to help us understand how to solve word problems. First, we're going to read, then we're going to underline, then we're going to choose, which means we're going to choose which operation to help us solve the question. Then we're going to solve, then we'll answer, and then check our work. So let's do that with this question and tick them off as we go. So first of all, let's read our question. Jenny has 2/4 of a pie and Mark has 1/4 of another pie. How much pie do they have all together? So we just read it. Let's give ourselves a tick. Whoa, let me just stop you there. Have you thought about subscribing to this channel? We're going to have daily videos that are going to help you with everything you need to know about maths. So if you're not a subscriber, click that subscribe button and join our little family. Back to the video. Now it says underline. Well, what do we need to underline? We want to underline the key information that's going to help us answer this question. So I'm going to underline the 2 fractions. They're going to be really important, aren't they? 2/4 and 1/4. But I don't think that's everything, because if I have 2/4 and I have 1/4, how do I know what to do with them? What do I put in the middle here? Well, I can see a key word here that's going to help me. It says all together. If I have 3 apples over here and 2 apples over here, and I want to know how many I have all together, I'm going to have to add them together. So guess what? That's what we're going to have to do with our question here. So my operation is addition. So I've underlined and I've chosen my operation. It's going to be addition. Now my next one says solve. Well, how do I solve 2/4 add 1/4? Well, I could draw it. And I could draw a chocolate bar over here that has 2/4 coloured in. 1, 2. And I could draw another chocolate bar underneath with 1/4. Just like that. So how many quarters do I have all together? I can see I have 1, 2, 3/4 all together. If you're not too sure about how to add and subtract fractions like that, go back to another video on this channel to help you with that, where it specifically shows you how to add and subtract fractions. You can also find it at themathshelter.com. So I've solved my question and I got my answer, and I'm now ready to check. 2/4, so I know I'm working in quarters. Is my denominator in quarters? Yes, it is. Good check. Add 1/4 equals 3/4. So I created my bar model up here. I split it into 4 into quarters. I got 2 and I got another 1, which gave me 3/4. Awesome. And look how helpful rucksack was to help me solve that. Your turn then, have a go at answering this question, and I would like you to use rucksack too to help you solve this. Write rucksack, write what each of the letters stand for, and then see if you can tick them off as you solve this problem. I'll read it for you to start you off. Alice has 4/5 of a bar of soap. She uses 1/5. How much does she have left? Good luck. Press pause on the video now. Put your answer in the comment section. Let's look at what to remember when solving word problems. Always use rucksack. Rucksack is really helpful to remind you to do all the individual parts. Write your word problem into a number sentence, just like we did here. And then remember, we must always check your work to avoid making any small mistakes.
Whoa, there you go. If you have just mastered this and you've done every part of this lesson, that means you can do everything in year 3 fractions. Easy, right? And it took less than an hour. But please watch this video again if you're still thinking little parts might be confusing. Going over it and over it and over it is how it's going to get stuck in your mind. Hopefully this video has been helpful for you though, guys. If you've not watched any of the other year 3 series lessons on the channel, you can see them all at mathshelter.com. But for now, guys, I'm going to say goodbye and I'll see you in another video. Peace out.